Hello, everybody. This is our final lesson this school year, actually. Finishing up lesson 8.2 from the geometry book on special right triangles. So last week we talked a little bit about the 45, 45, 90 and how the sides of those triangles all relate to each other regardless of the lengths of them. And then today we're going to talk about the 30, 60, 90 special right triangle. And just kind of like the 45, 45, it's special because, once again, its three sides will always maintain the same relationship. I do apologize, I don't have the actual notes sitting in front of me, but I am going to be pulling the examples that come directly from those if you are a student that's following the notes and printed those off. So we'll start off by just talking a little bit about the theorem itself and just basically discover how the three sides do relate. So one thing that you'll notice now is that because we don't have two equivalent sized acute angles, like in the 45, 45, 90, the legs that are opposite of them are no longer going to be the same. And we kind of learned, or you learned last year, that sizes of angles kind of determine side lengths opposite those angles. So if you're looking inside this triangle, you've got a 30, a 60, and a 90. So obviously, and you can even kind of look at, based on the way the picture looks, the shorter side of the triangle should be opposite of the smallest angle, 30. So this S right here is the short side of the triangle. And then more specifically, because it's one of the sides that form the 90, it's actually a leg. So we'll call this the shorter leg. So they have denoted the short leg of this triangle as S. You could call it X, whatever you want. They just chose the variable S. So if you look at how they've labeled the other two sides, and obviously this would be the medium side length, and this would have to be the longest because, of course, it's the hypotenuse. This would be the medium because it's opposite the medium-sized angle. They are also both written in terms of S. So that really tells us that these two sides relate back to the length of the short leg. So if you know the short leg's length, you're going to easily be able to just double it to find the hypotenuse because it's 2 times S, that length. And then also just as easily multiply it by root 3. And we've already done quite a bit of work with radicals, so multiplying a radical by some other value shouldn't be that big of a deal to get you the medium length side, which is in fact the longer leg of this triangle. So I'm going to kind of use my own symbols for this. So I'm going to use SL for short leg. I'm going to use LL to represent long leg. And then, of course, the H will represent our hypotenuse. So the two equations that we're going to pull from the relationships of the sides and apply, and this 30, 60, 90 would be, first of all, that the hypotenuse, I think this is the easier of the two, is equal to double the length of the short leg. So if you know the short leg, you're going to multiply it by 2 to get the length of the hypotenuse. And then also think about what you would have to do to go backward. If you know the hypotenuse and you just want it to be S, you want the short leg length, how would you get rid of that 2? Well, right now 2 is being multiplied, so you would have to end up dividing by 2 or cutting the hypotenuse in half to get that short leg length. So for now, we're just going to do this. Hypotenuse equals 2 times the length of the short leg. You can even imagine just kind of rearranging this. Solve this for short leg, you'd have to divide by 2, divide by 2. So you would get your short leg equals hypotenuse divided by 2. So that's one equation we're going to work with. The second equation is how to come up with this long leg length. So that's what earlier we said LL represents long leg. And if you look over here at this diagram, to get it, you're just simply going to, once again, take the short leg length, and now you're multiplying it by the square root of 3. So take the square root of 3 and multiply it by short leg. And then this might require you guys to kind of go back and think about all those properties of radicals, and when you multiply radicals, how is it done? And of course, simplest radical form would still be important there. We're going to keep all of these answers exact. Okay, so let's go ahead and just do the examples. And again, I'm pulling these right from the note packet if you are somebody that printed that off. So we're going to be taking a look at this first one, example 3. I'm probably not going to do all this stuff here. Oops, just wrote on my computer. But I will do each of the examples. So let me quickly throw down the diagram. So we have our 60 here. This is X, this is Y. I don't have to label the 4 or the 30, hopefully, because it's kind of assumed that if that's 60, that'd have to be 30, especially with that 90 there. So looking at this triangle right away, you know that it is a 30, 60, 90, right, triangle. So you know that the sides have special relationships. And looking at what they've given us the side that's opposite of the 90. So we know the hypotenuse. And we know that the only connection we can make in the beginning is the fact that the hypotenuse is equal to double the short leg. So some students are probably, I'd say most of you are probably just going to throw this formula down. So I think that's probably what I'll do here too. But some of you might get to the point where you're like, oh, I have to do is just cut that in half. And if you get to that point, awesome. If not, just continue to throw down the formula, because you will come across this again next year in concepts. Maybe you will be to that point by then. So we have this equation, hypotenuse equals double the short leg, or 2 times the short leg. And in this problem, I know the hypotenuse. So I'm going to take the length of the hypotenuse and I'm going to plug it in for the hypotenuse h. So 4 square roots of 3 is now equal to 2 times the short leg length. And now I'm just solving for short leg. And you could even technically have done this, short leg. And this problem is x because it is opposite of that 30-degree angle. So for me to isolate x, now we're just back to algebra. Right now I have 2 times x equals this. I just want x. So if it's being multiplied by 2, the opposite of that would be to divide by 2. So over here, those cancel. You can bring down x or SL, whichever one you want to bring down. As long as your final answer has x equals, because obviously looking at the picture, if you just say SL equals, I'm going to say, well, tell me which one is SL, which shows me that you understand which of these sides is actually, in fact, the short leg. All right, and then over here, for us to divide this by this, I can only consider the 4 and the 2 because both of those are hanging out outside of the radicals. There is no radical down here, so that root 3 is stuck. One thing you would want to think about, though, is whether or not you can break down 3. You can't, so 4 halves is 2, so this will turn into a 2. That's a 1. 2 over 1 is just 2. So I'm going to say 2 square roots of 3. And then looking back at the picture, they did not give us units, so we would just leave it there. If they did say like inches or feet, you want to just tack those on at the end there. So that gets x, the short leg. Now let's talk about the long leg. So for us to find the long leg, go back up to this equation again, we only know the relationship of the long leg to the short leg. So we're going to have to use the answer that we just came up with for the short leg. And hopefully it's right, because if it isn't, obviously this is going to be wrong. We know it's right, though. But that kind of just showed you the importance of taking your time and getting that first answer right, especially if you're going to use it to find the next answer. So we're going to have to use the short leg length, multiply it by the square root of 3, and that will get us, in turn, the long leg length. So again, I'll just throw the formula down. Long leg is equal to the square root of 3 times your short leg. And then I'm going to substitute in for the long leg the variable that they're using to represent it. So y is equal to the square root of 3 times, and we just found out that the short leg is a length of 2 square roots of 3. All right, and this one's actually pretty easy. If you guys remember back in radicals, when we were actually still in the classroom when we talked about this, you can imagine a 1 out there. So 1 times 2 would give you a 2. And then anytime we came across a radical times itself, we said it was the radicand. So you're still multiplying though. So the 1 times the 2 gives you the 2. The root 3 times the root 3 just gives you a regular 3. You still need to take those 2 and multiply them together. A little side note though, to show you why a radical times itself is the radicand. If you did do root 3 times root 3, you'd say, well, that's root 9, because 3 times 3 can be combined under one radical, and the square root of 9 is a perfect square, is just 3. So this is just like a little shortcut. And then, of course, 2 times 3 is 6. So now we know that y, let's throw this down here, y is equal to 6. So given the hypotenuse, we were able to kind of, I know we didn't really work backward, but we'll say that, work backward to get the short leg. And then once we had the short leg, we could then go ahead and use that to get our long leg length. So easiest situation is going to be this. If you're given the short leg, you can just quick find that, double it, and multiply it by root 3. When you're given one of these two, that's kind of more of like a working backward, because you're going to have to always go back and first find this so that you can go ahead and find the other dimension. So you're hoping that they give you that to begin with, because that's the easiest situation to find yourself in. All right, next example we have. Diagram looks like this. So now we're at example 4 in the note packet. Just a little sketch here. So here's your 60 again. 30 would be up there. I'm not going to tuck it in the corner though. So we have, oh, that's an F, not a T. F, 18, and D. So in this problem, again, no dimensions, but what they did give us is this 18, and because it is opposite of that 60-degree angle, this is our long leg. So that makes me think right away of the equation that has long leg in it, and then we know that the long leg is equal to the square root of 3 times the short leg. So we're going to have to start there. So what we're going to be able to figure out is the length of the short leg, which is the variable d on this diagram because it's opposite of 30. So we're going to go ahead and plug in that 18 for the long leg. So 18 would equal the square root of 3 times, and I'm going to also plug the variable that they're using to represent the short leg in here. You could keep it SL if you want, as long as at the end of the problem you say that d is equal to. All right, so to solve for d, right now it's being multiplied by that. Opposite of that would be to divide. So we're going to divide both sides by root 3. Over here, we're left with d. Over here, what we're left with initially is 18 over the square root of 3. But we all know at this point in the year that we never leave radicals in the denominators. This is where you're going to have to rationalize your denominator. So you want that 3 to turn into a perfect square. So I'm going to multiply it by another 3. And for that to actually be able to happen, it has to be under a radical. So I'm going to come over here and do root 3 over root 3 because that equals 1. So that's not changing the number, but it's going to get me to the point where I can down here say, well, that's just root 9, which is just a 3. So top times top would be 18 square roots of 3. And then down here, again, that little shortcut, a radical times itself is the radicand. And then last thing you'd want to check for is these numbers that are hanging out outside the radical. Can you reduce them? Well, I know that 3 times 6 is 18, so I can reduce that to just 6 square roots of 3 equal to d, which remember is your short leg length up here in this picture. So now that we have this equal to 6 square roots of 3, we can use that information to come up with the hypotenuse, which is the variable f. So let's start with this though. Hypotenuse we know is equal to 2 times the short leg. The hypotenuse, they've used the variable f to represent, should equal 2 times the short leg length, and we just found that to be 6 square roots of 3. And this one's pretty easy because the only two numbers that you can actually multiply are the 2 and the 6 because they're the only ones that are outside the radical. So f would equal 2 and 6 multiply to give us 12 square roots of 3. So there we have our hypotenuse. All right, next example is on the following page. So we're looking at 1, 2, and 3. I don't know that I'm going to do all of these. So we've done one where they give us the hypotenuse. We've done one where they've given us the long leg. Why don't we do... We'll do one more hypotenuse and one short leg. So we'll do 1 and 2. So for number 1 on that page, we have this triangle. Here's our 60. That's a 1. That's a y. That's an x. This would obviously be your 30. Leaving answers in simplest radical form. So the one they've given us is opposite of that 30, therefore it must be the short leg length. So I'm going to come over here, and it doesn't matter what you find first here because we know both of these relate back to the length of the short leg. So I'm going to jump to the hypotenuse first. I know the hypotenuse is 2 times the short leg length. The hypotenuse is represented by the variable x. So x would equal 2 times the short leg length is 1 unit. So the hypotenuse is just simply 2 units because it's always double the length of your short leg. And then we know the long leg is equal to the square root of 3 times the short leg. So the long leg, which they've used y to represent, would equal the square root of 3, once again, times 1. And 1 times anything is itself, so that's just going to give us the square root of 3. So you can kind of see, and even if this had been something other than the number 1, this is still easier to do than working backward off of either a hypotenuse or a long leg. All right, we'll work backward though off of one more hypotenuse. So number 2, we have a 9, an A, a B, and then we have, this is our 60-degree angle, and 9 is the hypotenuse. We're going to have to start with this equation. The hypotenuse is equal to 2 times the short leg. So if I plug in the 9 for the hypotenuse, that would equal 2 times the short leg here is represented by the variable A. So if I solve this for A, we would divide by 2, because it's being multiplied by 2. I've got a fly hanging out around here. Divide by 2. And then we're probably going to actually keep this as a fraction because it'll be a little easier to work with down the road. So those will cancel, bring down your A, and then that would equal 9 halves. Some of you might feel more comfortable doing that, which is fine, but I'm going to go ahead and keep it as 9 halves. So A is 9 halves. And again, A is the short leg. And then once you've got your short leg, then you should be able to come up with your long leg. So long leg is equal to the square root of 3 times the short leg. The long leg is B in the picture. And that should equal root 3 times 9 halves, or 4.5 if you want. I'm going to think of this as root 3 over 1. That way I can multiply fraction by a fraction, numerator times numerator. So I just have to kind of push those together because the 9's not under a radical. So that'd be 9 square roots of 3 over 1 times 2 is just 2. And that would be the length of your long leg. All right, so that's example 2. I guess we'll do one more, number 12, where they give you another short leg. They didn't give you a picture here, but the shorter leg is 6 feet long. Find the length to the nearest 1/10 of a foot of the other two sides. I'm actually not going to follow those directions. I'm going to keep it exact because that's preferred typically to rounded answers. So if our short leg, I'm not even going to draw a picture here, is equal to 6 feet, I know that the hypotenuse should equal 2 times the short leg. So the hypotenuse should equal 2 times 6. Therefore, the hypotenuse would be 12 feet. So there's one of the other sides. And then the long leg should equal the square root of 3 times the short leg. So the long leg would equal the square root of 3 times 6. And this is a situation where you just push them together because one's under a radical and one is not. So you put the 6 kind of like a coefficient on that radical. So 6 square roots of 3, and just throw your units on there, feet. So again, when they give you that short leg, that's the easiest situation you're going to find yourself in. All right, last question is where they give this kind of another trapezoid type question like we had in the 45-90. Doesn't really have, I guess it does have a number. It's number 15. So it looks like this. So we have a 60-degree angle here. This side is 2 square roots of 3, and we know that because it's a trapezoid. These are the bases, they're parallel. Tells us those are 90, which they should be because they're adjacent angles inside of a quadrilateral. And they should always add up to the 180 there. Let's see what else. We have an A here, we have a B here. So what we would need to do, I forgot this 5 up here, is the first thing is go ahead and drop a dotted line from this vertex up to this base, hitting it at a 90. So we know that if that's 90, we know this is 90. Same thing down here, this would have to be 90. And then what we've just done is we've formed ourselves this triangle over here. So if this is 60 and this is 90, this would have to be 30. So on this triangle, let's see what we know. We can carry this side of the trapezoid. We can just kind of think of sliding that over to this dotted line that we created. Those are the same segment. So if that's 2 square roots of 3, this is also 2 square roots of 3. And we could go through and prove why that is using quadrilaterals. We're not going to do that right now. So that's 2 square roots of 3, and it is opposite of that 60-degree angle. That means that we know the long leg of this 30, 60, 90. So I'm actually going to come over here really quick. Just focusing on this 30, 60, 90 triangle. We know the long leg is 2 square roots of 3. And looking at the diagram, they do want to know A, which happens to be the hypotenuse. We do not have a direct connection between the long leg and the hypotenuse, so the first thing that we're going to have to do is we're going to have to find the short leg. The picture did not ask for it, but I think we're going to need it to find B. So just keep in mind this 5 that's here, that 5 was there in the beginning. It's referring to this whole base. So if we're about to find from here to here, we're finding part of that 5. So why don't we go ahead and do that? So we know that the long leg is equal to the square root of 3 times the short leg. I think this will kind of work out nicely for us here. The long leg is 2 square roots of 3, which should equal the square root of 3 times the short leg, and we'll just keep it SL because there is no variable in the picture for that. And then to solve this, we divide out that square root of 3, and look what happens. There's already a root 3 above, so those just cancel. So we get a nice clean 2 left behind for the length of the short leg. So if we can come up to this picture and throw in a 2, What I now know is this: if this whole thing was 5 and just this portion of it was 2, that means that from here over to here must have been 3. And if that's 3, that means that the opposite side, the other base, would have to be 3. Just a minute. Would have to be 3. So we actually just found our B value. So B is equal to 3. I don't think we have any units on this problem. So B is 3. All right, and then let's come back to the triangle here. I kind of just went to the side note there because it was kind of easy to come up with that. Back to the triangle. Now that we know that this is 2, that's the short leg. We can use the short leg to get the hypotenuse, and I think maybe at this point in the notes, we know that the hypotenuse is double the short leg. So this is what I'm talking about for some students that kind of catch on. They don't have to write the formula down every time. You're just going to say in your head, well, I'm just going to double that to get that. 2 times 2 is 4, therefore the hypotenuse is 4. So typically, if you come across one of these trapezoid problems, which I don't honestly think you're going to have any of these on your practice worksheets or even in the Delta Math, but we would have had a lot of these had we been in the classroom. So that's why I'm still showing you a few of them in the notes. Typically, you're always going to throw down a dotted line that's going to hit one of the other bases at a 90, and it's always going to form you either a 45-45 or a 30-60-90. That's going to allow you to fill in the missing pieces of that puzzle. Alrighty, so that concludes 30-60-90s. It also concludes new lessons for the year. Hope everybody's doing well, and as always, just feel free to email me if you have any questions.